Hey everybody, welcome back to the channel. As promised, today we're going to go over sharpening a small carbide end mill and a sensitive workhead. Now last week we went over using the air bearing to do this, and using this fixture is so much easier. This thing is purpose built to do nothing but sharpen the sides of end mills. And so today, as we work our way through with the sensitive workhead, we're going to go through what all the additional challenges are. To be perfectly honest, I'm not looking forward to doing this. I've never actually done this before, especially on like something so small as this. And I'm not even certain that it's going to work out. But we're going to talk it through step by step, and we'll see what happens in the end. The first thing I've done is I've dialed my sensitive workhead in the two directions that are going to matter. And that's no big deal to do. But both of those steps are additional steps because that air bearing fixture gives you both of those for free. All you do is throw the fixture up and you already have it dialed in both directions without even trying. If you didn't see the video last week, I'll put that somewhere at the end. I'll put it either an end screen or a link or something like that, so you guys can check that out if you're interested. When it comes to wheel selection, now this is exactly the same. You can't be wanting to grind across a great big flat surface like this. And so I've got the same wheel here that we used last time. The wheel comes to 90 degrees. I've got my head set to 45. And what that gives us in the end is a nice sharp line here. We're going to do all our grinding on a line. The next thing I've done is I have my wheel at exactly the same center height as my sensitive workhead. Now that's not absolutely necessary, but it is going to make setting up our clearance angle a little easier than it would be without doing that. The reason is that at the center height of this wheel, if your tooth face was perfectly level, you would basically have no clearance at all. And so by putting this at center, instead of it being round, essentially it becomes a straight line. So I can rotate my end mill up a calculated amount, and that straight line will translate to the clearance angle that I'm looking for. I hope that makes sense, but I'll explain more as we go. Now this is where it starts to get interesting, because with this setup we have to position our pointer finger manually, and its placement is incredibly specific, and that's going to take some time and some screwing around. Whereas with the air bearing, you get all that for free. There's handles to adjust the position of your pointer in and out. You can adjust your pointer up and down, and the beauty of this setup is once you set your pointer to a given position on your tooth face, throughout the whole process it stays there, because this entire fixture, including the pointer and the tool, travel together as one unit towards the wheel. Whereas with the sensitive workhead, the wheel and the pointer are going to be fixed, and the tool in the fixture is going to travel in and out. And so at various times throughout this process, the pointer is going to be touching different spots along the face of the tooth. So this is going to be painful, this is going to take a while, so I'm going to do this off camera, but then we'll come back and I'll explain everything that I've done and what I feel is important about each feature. So here I am with my fingers set up. A couple of things that I was shooting for here is my pointer is just to this side of the high spot on the wheel that's actually going to do the cutting. And the idea there is that I can get my tooth up under the pointer before it contacts the grinding wheel. So that was something that was important that I wanted to accomplish. If you look over here, get in there real close, you can see that my pointer is very close to my wheel but not touching. I wouldn't want it touching because that means the high-speed steel pointer would be running down the cutting edge all the time, and I wouldn't want that. But I do want it quite close to the wheel because I have a very limited tooth face width here to be pointing off of. The way I imagined this working then was I would come in, I would get my tooth face up under my pointer, and then I would rotate my sensitive workhead as I was moving my table along. But the problem is, with this being such a small diameter and the pointer being so close to the center of rotation, I have so much torque over that with this big handle, and there's enough friction in the bearings in here that if you look real closely, you can see that despite all my best efforts, that pointer is wanting to wiggle around. And so there's pretty much absolutely no way with my dexterity and the rigidity of this setup that I'm going to be able to follow that thing all the way to the back and then all the way back out and end up with a nice consistent cut. So I'm not ready to give all the way up yet. It's certainly not going to work the way I imagined it working. But what I'm going to do now is I've touched off on the edge of my end mill, and I'm going to come, I know where my zero is, where I touch. I'm going to come out, I'm going to feed this thing to the end of travel, and then I'm going to come in, I'm going to get that cutting edge up under my pointer as I'm getting close. I'm going to try not to flex that pointer, although a certain amount of what's going to happen is just what's going to happen. But now what I am going to do, once I'm to my depth and touching the wheel, I'm going to let the pointer rotate the tool as I back the table out. And now the pointer is still flexing, so it's going to be gross, but we're going to see if we can't get some kind of cutting edge on there. Then when I'm all the way off, you can see that pop, and there's pressure like crazy. Then I'll come to the next tooth and we'll come to the same zero, and then we'll back it out and we'll see if we end up with anything at all. I've got most of the damage out of this now. When I feel the actual cutting edge, it feels kind of got a little serrated feeling to it, and that's because my wheel's been turning, grinding up past the cutting edge and dulling it slightly. So although most of the damage is gone, it's nowhere near sharp. To make it sharp, we're gonna have to reverse the direction of our wheel, which is going to force it away from the pointer. And so the possibility for a crash or a disaster here is gonna grow when we do that. But it's the only way to make it sharp, and I don't think it's the sort of thing that could lead to me or my machine getting hurt in any way. It could certainly wreck this tool, but in the interest of carrying on, we're gonna give it a shot and see what happens. So certainly not what I was hoping for or even what I expected, but also not a complete failure. I'd say don't go making this your plan really, but let's say that you're just trying to get a few more miles out of an end mill or something, and this is all you have available to you. We did make it sharp, much sharper than it was when it came in here, and it's not horribly out of true in any way, and it will definitely cut. So again, I'm not happy with the results of this, but we're just sharing it with you guys. It was something we tested. I wouldn't say it's a complete failure. I wouldn't say it's a complete win. It is possible. It's hard as heck, so not really recommended. Well, that's going to do it for this video, guys. I hope you enjoyed. We're going to file this under the not a complete failure category. We'll see you guys in the next one.